So, measures of central tendency. That is, how do you find the middle of a set of data? Okay, if I have a list of test scores, how do I find the middle? And there's different options. So we kind of need to talk about what our options are and when each one might be appropriate. If I tell you to find the middle, what are your thoughts? Can you think of me? What did you say? Mean. That's usually the common one. You know, if you want to know your typical test score, you can find your average, right? So most of the time when we think about the middle, we think about mean.
I don't even know which one that is.
So measures the central tendency. That's just a numerical value to describe the middle or the center of a set of data. Mean, sometimes you'll hear it called arithmetic mean. It's just an average. How do you find an average? Add them up, divide by the number you have. Notation-wise, it's the same calculation both ways. But as sample, typically we use x with a line over the top. We call that x bar to mean the mean of a sample. And we get it by adding up all of our x's and dividing by n. This symbol right here, this weird looking E thing, it just means add. So we add all the x's. It's a summation. Calculation is the same way, but it's a different variable. Stats uses a lot of Greek letters. So there's this weird looking U, has a really long tail in front. It's called a mu, M-U, mu. So x bar, mu, those are both a mean. We just see a different letter if the data was a sample or a population. You'll get used to that as we go through, and you'll get used to knowing that both of those are mean. But the nice thing about this formula sheet, if you forgot which is which, if you look under chapter 3, the first two bullets have these. And so it says population mean, mu equals. So we know mu is the population. Sample mean, x bar equals. So we know when we see an x bar, we're dealing with a sample. So this has the letters that we use. All right. So let's just try one. It's been a long time since we've actually done a math calculation in this class. So let's do some math. If I want to look at this data, so the following data represent travel times in minutes to work for all 7 employees of a startup web company. I want the population mean of this data. Why would it be a population?
There's only 7 employees that work there.
Right, it was all 7 employees. I didn't say 7 of the employees in the school. If I were talking about 7 of the people in the school, would it have been a population or a sample?
Sample.
Yeah, in that case it would have been a sample because there are more than 7. But here, that's everybody. The only thing that changes is the label on it. Okay, so it's a population, so it's mu. You add them all up. So grab a calculator. Let's add them all up. What did you get? I got 174. What did you guys get? And what would we divide by?
Oh, that's a
7, because we have 7 employees. And our mean, 24 point, didn't work out perfectly. Let's at least keep a couple minutes, or a couple decimals. So our population mean, 24.86. So it takes approximately 24.86 minutes. All right. Part B. Take a simple random sample of 3 employees. and then find your sample. So pick any three. Does it matter which three? Alright, so we just picked three. Which ones do you want me to use?
18, 5, and 26.
18, 5, 26.
I guess that wasn't really random.
That's okay. So if it's a sample mean, what would I call it?
Bar X. X bar.
X bar. So if we add those up, 18, 5, and 26, what do we get? 49. This time we would divide by 3.
16.3.
Okay. If you pick a different sample, will you get the same thing? No, you get a different one. Alright. Any questions there? Normally I would tell you, I just wanted you to see the different notation. Alright, so another way. Mean is one option for finding the middle. Second option is the median. Have you heard this term before? Mean, median. So median in here, typically a capital M will represent median. And that's just the middle if your data is in order. So if you write your numbers from small to large, the one in the middle is your median. The key to this, though, for it to work, you have to put your data in order first. It can't just be at random. You know, we have to list the numbers from small to large. So if I go back to the example we just did with our 7 employees, and I asked you to find the median. Okay. So same example, you don't have to rewrite it. Are these listed in order? No. So first thing I have to do is write them in order. So we would have 5, 18, 23, 26, 36, 43. So what's in the middle? Basically, think of it as marking off your high and low. What if you came down to two numbers left? You averaged. So if I had like 23 and 26 both left, you would add them up, divide by 2. But here our median is just 23. Alright, so far so good? Mean and median? So I want to take this same example, but I'm going to change it. So let's say we just hired a new employee. So now we have someone who has a 130-minute commute. We want to find our mean and median now. Okay, so same first 7, but now we have another person. So our mean, if we add them all up, including our commute of 130, 3 or 4. And what would I divide by now? 8, because we have another employee, so 8 total employees. And what's our mean?
It goes up 1 more.
My median.
Oh, I was going on the next one.
Okay. So you guys probably already have this data listed from our previous example. So we have them in order from small to large. Where do we put the 130 at the end. Okay, so now if I find my median, I'm left with a 23 and a 26 in the middle. So if you have two numbers like that, to find the middle, you add them up, divide by 2. And we get 24.5. Is everybody okay with that? So let's compare. What was my original mean? So mean started at 24.86. I hired this new employee and it went all the way up to 38. So that one employee had a really big impact on my mean. So this is a large increase. Okay, what about my median? Before the median was 23, now it's 24.5. We're talking in minutes. Is going up by a minute and a half that big of a deal? No. So this is a small change. Okay, so this kind of illustrates the strength and weakness of both of these measures of central tendency. A mean is the best. It gives us the average, tells us the most information. But one person can really throw it off. Okay, if I'm entering test scores on Infinite Campus and somebody was absent and I put in a 0, what does that do to my test average? It drops it way down. Does that number really reflect how my class did anymore?
No.
No. So the mean, if you have one really high or one really low value, it changes significantly. The median, it doesn't do as great of a job of giving us the average or the middle, but if you throw in a high or low value, does it change it a whole lot?
Yeah.
All right, it's very minimal change. So the median is what we call resistant. So if I were writing this down, I would just say resistant, and that means extreme values do not affect its value. Okay, so in our terms, the median is resistant. And a high or low value won't change it much, but the mean is not. One weird value will change it a lot. So this is just kind of a picture to kind of illustrate the relationship between mean and median, and also in terms of our data. We've talked about skewed and bell-shaped a lot, and that is going to continue to come up. So if your data is skewed left, that means we have more low points. Then what happens is your mean is smaller than your median. So if it were me, I would probably just draw this little picture, even if you don't even put the lines. Just draw the bell curve. So you know skewed left, that means the mean is less than the median. Because what happens if you have more low values, it's going to draw down your mean. It will make your mean get smaller. If your data is bell-shaped, then your mean and median are going to be the same. So if it were me, I would just probably draw myself a little bell curve and say mean equals median. If it's symmetric, bell-shaped, mean and median are the same. Finally, if it is skewed to the right, that means we had more high values, and so those high values are going to cause your mean to get bigger. So if it's skewed right, the mean is going to be bigger than the median. So if it's bell-shaped, mean and median are the same, or if it's symmetric, I keep saying bell, but we said symmetric when I first told you that, right? They mean the same thing. Which one did I say?
Bell.
I said bell the first time? Okay. So bell-shaped, mean and median are the same. If it's skewed to the left, it means we have more low values, so the mean is going to be smaller. Skewed to the right, we have more high values, so the mean is larger.
Why on the picture is the bean smaller?
It's
skewed right.
So it's saying, when it's talking about the value, think of it along the x-axis. So if you were trying to take mark,
Okay.
think of it there, not in terms of the height. Other questions? So what I'd like to do now is show you how to use your calculator to do some of this. The data set we just had, that was small, nice numbers, no big deal. But if I give you a lot of numbers or really big numbers, the probability of us making a mistake goes up, right? So let's say I gave you this set of data. This is the asking price of homes for sale in Lincoln, Nebraska. We are going to use our calculator to find this. What you need to do on your calculator, you are going to go into Stat, Edit. If there is data in here, remember, do not delete the list. Go up onto the title, hit Clear, Enter. And you need to put all of this data in L1. Okay, so don't do 2 columns, even though it's split in 2 columns here. Everything goes in L1. You have all these numbers in your table. If you go to Stat, okay, Edit is where we change the list. If you go over onto Calculate, this is all the stuff our calculator can find for us. We only have one list of data, so I'm just going to go into one variable statistics. So the first option. List, we all put it in L1, so we shouldn't have to change that. Does this say L1 on everybody's calculator? Okay, the rest of the stuff you can just enter to get through it. And it brings up this slide. So the mean is which number? Yep, so our mean is the X bar. That's not what I want. So the average here is $123,193 and about 38 cents. The median, if you scroll down, it says MED. So our median is listed right here. And it tells us a lot of other stuff. Some of it we'll eventually talk about, but not today. Right now we're just looking at the mean and median here. So if your median is the same but mean is different, that means you mistyped probably 1 point. Alright, does anyone need help finding those on here? If your numbers don't match, it just means you mistyped one, not a huge deal. Okay. So are those, if data was bell-shaped, those would be the same. Are they exactly the same? No. No. Which one's higher? Median. The median. So that means our middle of the data is here, and the mean is smaller than that. So that means we have, I have more low values. We could check that. Remember, we did histograms on here if you wanted to look at your data. So we went into my stat plot. And you guys don't have to. I just wanted to confirm that this is what we said. This is what that histogram looks like. Is that skewed left like we said? Yeah, because my mean was smaller, so we had more low values. I turned on plot 1. The histogram. Go into stat plot. Is yours not going into calculator?
I forgot to press enter, so I didn't.
Oh. Do you want to use this one for a second? Just try it.
I wrote it.
Okay. The other thing, just as a side note, if you wanted to compare 2 sets of data, I think there is like one question on the homework where it gives you 2 different things and asks you to find the mean and median of each. You can put them in one at a time. You could also like enter both sets. So put one in the first list, one in the second list. And when you go to calculate, since I have two different groups now, I could say two variable statistics and tell me X is the first one, Y is the second one, and hit enter. And so you'll notice it tells me the mean for X, and then down here is the mean for Y. So if you have multiple lists, you can put them in at once and ask it to do both. And then if you scroll down, it'll tell you, like, eventually, different things. So that is an option, but you can also just put them in separate. Okay. All right. One last option for finding the center: mean, median. What else? Mode. Remember hearing about mode before? So mode is the one that occurs most often. So mode is the most frequent observation. It could be more than one if we have two values that tie for showing up the most times. It's also possible that we won't have a mode if there is no value that gets repeated. If we look back at our list of commute times, what was the mode for that one? 23. That was the only one that got repeated. It showed up twice. If another value also showed up twice, we would have had two modes there. If we didn't have anything that repeated, there wouldn't have been a mode. So we always have a mean and a median mode. Sometimes we do, not guaranteed. I want to do just a couple last examples and then I am done. So let's say a data set has the following values. 11, 15, we're missing the next number, 24, 29, and 31. If the median is 20.5, what is the missing value? So there's one very similar on the homework. How do we find median? That's mean. Yeah, we find the middle. So we don't know this one. I could even call it X right now if you wanted to treat it like an algebra problem. Okay, so median, we kind of start on the outside, work our way to the center. So to get the median, those two numbers are in the middle. So we would have to add those up and divide by 2 to get our median. But what is the median equal to? Can we solve this equation? Multiply over the 2. Subtract our 24. And then let's see, value is 17. Is that okay? The last one, I just want to look at a problem in our book. So if you turn page 129, problem 32. So this problem says Mr. Zuro finds the mean height of all 14 students in his statistics class to be 68 inches. Just as Mr. Zuro finishes explaining how to get the mean, Danielle walks in late. Danielle is 65 inches tall. What is the mean height of the 15 students in the class? Okay, so how do we get the mean? We add them all up and we divide. So originally, He added them all up. I don't know what he got when he added them all up. I'm going to call it x. What did he divide by? 14, and our mean was 68. Now I can't go back and figure out what those original 14 numbers were, but we can find what they all added up to. So if we multiply over the 14, 952. That's the first 14 students when I add their heights. So now our new average, the first 14 add up to 952. What's the next person add in?
65.
And what would we divide by this time? 15, because we have another student.
67.8.
And so now the height is 67.8. So I didn't figure out the original 14 numbers, but I could find what they added up to and find our new average. Any questions? So that is it for today. In terms of a graphing calculator, I would say number 19, I would maybe do that one first. That's one where you probably want to find your mean and median on your graphing calculator. It's just a bigger set of numbers. You don't have to, you can certainly do it by hand, but if you want to save yourself a little headache, that's the biggest set of numbers. And if you want to use a calculator, you can start there.